Energy storage is just as important as energy generation. Free energy experiments, magnet motors, over-unity systems, and solar setups all share one challenge. Where do you safely store the energy that you harvest? Without reliable storage, the benefits of generating free power can easily be wasted. That is where the idea of a DOI-free energy battery box comes in. This project focuses on creating a strong, safe, and weatherproof storage unit that protects your batteries from damage while ensuring they operate at their highest efficiency. At its core, the battery box is more than just a container. It is a controlled environment. Batteries are sensitive to temperature, moisture, and mechanical stress. Exposure to rain or direct sunlight can shorten their life, while poor ventilation can lead to dangerous overheating. A well-designed box solves all of these issues. It keeps moisture out, regulates airflow, prevents accidental contact, and makes the system both safe and portable. For anyone experimenting with free energy, such a box becomes the foundation of the entire setup. The first consideration is safety. Storing energy always carries risks, whether it is with lead-acid, lithium-ion, or other experimental battery types. A short circuit can lead to sparks or fire. Overcharging can create pressure and leaks. The box must be designed to reduce these risks. Insulating materials, non-conductive interiors, and protective fuses should be incorporated. This way, even if something goes wrong inside, the box contains the problem instead of spreading it. Equally important is weatherproofing. Moisture is the enemy of electricity. Rain, humidity, or condensation can corrode terminals and damage electronics. The DIY battery box should use seals around its edges, water-resistant coatings, and slope designs that allow water to run off rather than pool on the surface. Even the placement of ventilation holes matters. They must allow airflow while preventing rainwater from seeping in. Many builders use rubber gaskets, silicone seals, or outdoor-grade plastic housings to achieve this. Now let us talk about structure. A good battery box must balance strength with portability. Thick plywood, marine-grade plastic, or lightweight metals such as aluminum are common choices. The material should be non-flammable and durable enough to handle knocks and impacts. For portability, handles or wheels can be added. If the box is stationary, then it should be anchored to the ground or wall, mounted for extra security. The goal is to ensure the box does not shift, fall, or tip even under heavy use. At this stage, you might be thinking that this sounds like building a miniature power station. In many ways, it is. That is the exciting part. When you create a safe and weatherproof battery box, you are building the heart of your free energy system. Imagine having your magnet-powered generator, solar panels, or experimental over-unity device feeding into a reliable storage hub that you designed with your own hands. The pride in that accomplishment is as powerful as the energy itself. Ventilation is another critical element. Batteries heat up during charging and discharging. If that heat is trapped, it can reduce battery life and increase risks. The box should allow air to flow in and out without letting in dust or rain. Passive vents near the top and bottom of the box can create a natural airflow cycle. For larger systems, small low power fans can be added, ideally powered by the batteries themselves. A balance must be struck between keeping the box sealed against water and allowing it to breathe enough to stay cool. Next comes the wiring layout. Inside the box, cables, connectors, and switches must be arranged neatly. Loose wires increase the risk of shorts, tangles, and unnecessary strain on terminals. Using cable ties, protective tubing, and labeled connectors ensures that the system is both safe and easy to troubleshoot. Including a fuse block or circuit breaker panel adds another layer of security, making sure that any sudden surge of current is stopped before it causes harm. Another exciting feature to add is monitoring. A simple voltmeter, ammeter, or even a digital display can be mounted on the outside of the box. This allows you to check the battery status without opening the box every time. For larger projects, wireless monitoring modules can transmit data to your phone or computer, letting you keep track of energy levels in real time. Monitoring does not just improve convenience, it prevents overuse and alerts you to problems before they become dangerous. Insulation is sometimes overlooked but highly valuable. Extreme cold can reduce battery capacity, while extreme heat can damage them. Adding foam insulation, reflective coatings, or double-wall designs helps keep the internal temperature more stable. In very hot regions, Reflective paints or sun shields can reduce heat absorption, while in colder climates, additional insulation helps retain warmth. The aim is not to make the box airtight, but to moderate the swings in temperature that can stress the batteries. At this point, let me ask you something engaging. Imagine leaving your experimental battery bank outside during a heavy rainstorm. What would happen if water seeped into the terminals? What if the box overheated under the sun with no airflow? That single moment of neglect could wipe out months of hard work. Now picture instead a sturdy, well-built box protecting your system, keeping it safe and running smoothly. Which scenario would you rather experience? That is the real difference that design makes. Customization is also part of the DIY spirit. Some builders prefer to make compact boxes for small portable experiments, while others design large stationary enclosures capable of storing multiple deep cycle batteries. Some add wheels, others add solar charge controllers inside, and some even integrate inverters directly into the box so that AC power can be drawn immediately. The possibilities are endless, limited only by your creativity and practical needs. Do not forget grounding. A battery box should ideally be grounded, especially if used outdoors. This reduces the risk of electrical shocks and provides a safe path for any stray currents. A grounding rod or plate can be connected to the system, ensuring that electricity has somewhere safe to go if a fault occurs. Grounding is one of those safety features that you hope you never need, but will be grateful for if the time comes. Durability testing is the final step. Before trusting your battery box with expensive cells or experimental power, test it. Spray it with water to check the seals. Place it under direct sun and monitor the temperature inside. Shake or move it to ensure the structure holds firm. Run your system for a few hours and feel for any signs of overheating. Only when the box passes these tests should it be considered ready for real-world use. Another important part is accessibility. While the box must be secure, it should also allow easy maintenance. Hinged lids, removable panels, or sliding trays make it possible to replace batteries or adjust wiring without dismantling the entire structure. Locks or latches can keep the box secure, but they should not make it impossible to service. Striking the right balance between safety and accessibility ensures the box remains practical in everyday use. Think also about aesthetics. A well-built battery box does not need to look like a rough prototype. Smooth finishes, painted surfaces, or decorative covers can make it blend with your home or garden. If it looks professional, it will not only inspire confidence, but also demonstrate that free energy projects can be both functional and beautiful. A project that looks polished is more likely to be respected and shared, inspiring others to explore free energy solutions themselves. For those who are passionate about off-grid living, a free energy battery box is more than a hobby. It is a step toward independence. Instead of relying on commercial systems or utility companies, you are creating your own storage solution tailored to your needs. In emergencies, it becomes a backup power supply. In daily life, it reduces reliance on the grid. The sense of empowerment that comes from building and maintaining your own system cannot be overstated. Now let us consider cost. Many people assume that building a weatherproof battery box is expensive. In reality, many materials can be recycled or sourced inexpensively. Old coolers, toolboxes, or even repurposed cabinets can be modified into battery boxes with some creativity and effort. By sealing the joints, adding vents, and reinforcing the structure, a common object can become a reliable energy hub. This DI approach not only saves money but also encourages sustainable reuse. The long-term value is undeniable. Batteries are not cheap, and protecting them with a solid box extends their life significantly. Each year added to the lifespan of your storage system is money saved and energy secured. Instead of replacing corroded or overheated batteries, you can rely on the same system for years. Over time, the investment in building a proper box pays for itself many times over. A DIY-free energy battery box is not just a project. It is a crucial part of experimenting with overunity systems, solar setups, and other free energy innovations. It protects your investment, ensures safety, and empowers you to store energy efficiently in any environment. By focusing on structure, weatherproofing, ventilation, wiring, insulation, and monitoring, you can create a professional-grade system from simple materials. This project is a reminder that free energy is not only about generation, but also about responsible storage. It is an opportunity to take control, innovate, and inspire others on the path towards sustainable, independent living.